Okay, we're looking at a question here where we want to express power in radical notation and then evaluate if possible. So we're going to begin by looking at a over here. First of all, remember every time you have a negative exponent, you rewrite that as 1 over that value and then to the positive value of that exponent. So in this case it would be 1/2. Now that 1/2 only applies to, the denominator here. Okay, so, because the numerator, it's not going to do anything. It'll remain as 1. So I'm going to get 1 over 64 to the 1/2. If you recall, that exponent just means the square root of 64. Or if you want to write the 2 right over there, you can do that, but it's assumed to be there. And finally, the square root of 64 is just 8. So my answer in this case will just be 8. Let's move on to the second. Okay, I have a negative 125. My exponent is 1/3. I can rewrite that as the cube root of negative 125, and feel free to plug this into your calculator, but essentially you're looking for a number that when I cube it gives me negative 125. Some reflection will yield the value of negative 5. Again, negative 5 cubed is this here. And keep in mind that it is also negative 5 times negative 5 times negative 5. Okay, that negative is not added at the beginning of your expression. For part C here, same thing. I'm going to write this as a cubic. So 27 cubed, and then I'm going to square that. And that gives me 27 cubed, cube rooted. It's going to give me a value of 3. Then when I square that, I get a value of 9. Moving on, D, it's almost identical to question C, except that I have a different numerator in my exponent, and my base is going to be negative, but that shouldn't pose any difficulty if I just rewrite it as such, and then raised to the power of 4. I'm still going to get a negative 3 down here, because negative 3 times negative 3 times negative 3 is negative 27 raised to the 4th, and I get a value of 81 positive. Last one here, a whole bunch of expressions. Let's see if we can simplify these one at a time. So I'm going to start by putting this one into this form. This guy here, this will be the 6th root. Actually, you know what? I'm not going to do that over here. I'm going to actually go the other way and write this as 8 5 over 6 times 8 1 over 2. Because I want to simplify this. I want to bring it together. I want to bring these two guys to have one denominator. One base. And then I have the last one, which will be, actually, because I have a negative exponent, I'm going to have a fraction. So 1 over 81 to the power of 1/4. Let's do our evaluation now. So the 4th root of 16 is going to be 2 cubed plus, this will become 8 to the exponent, and again I'm adding these together because when I have the same base I add exponents. So 5 over 6 plus 1 over 2 minus the 4th root of 81 and 1. So the 4th root of 1 is 1, and the 4th root of 81 is going to be 3. Okay, which I'll write it there for now, and let's put it on the next line. So I got 8 over here plus 8 to the exponent. What's that going to be? 8 over 6, because what I'm doing here is I'm multiplying these together, so times 3 times 3. So adding them together, I need a common denominator, and that gives me 8 over 6, which, by the way, simplified is 4 over 3 minus 1 over 3. And can we go further? Yes, we can. So I get the cube root of 8 to the exponent 4. Still minus 1 over 3. And the cube root of 8 is 2. So I get 8 plus 2 to the 4 minus 1 over 3 equals 8 plus 16 minus 1 over 3. 24 minus 1 over 3. If you want, you can write it as just a mixed fraction. That would be 23 and 2/3. Or if you prefer, you can write it as an improper fraction, where I get a common denominator. That's 24 times 3, which will be 72 over 3. And then minus 1/3, which gives me 71 over 3. And that will give me my final answer. There might have been, definitely a quicker way to get that, but that's okay. It's one way. I guess the first way that came to me. Maybe if you see some other shortcuts, give it a try and see if you can solve that one a bit more quickly.